Hello everyone. In this section, we will introduce the calculation of walk measure and the sample size. The walk measure is a process to determine the right standard time to finish a job. We start from the observed time, which is defined as the average of all the observed time. And from the observed time, we need to consider the performance rating, which considers the difference between people's normal working time and the observed time. So by adjusting the observed time, we can get the normal time. After we get the normal time, we use the allowance factor to introduce different allowance, including the personal allowance, job allowance, etc., etc. Now let's take a look at how do we calculate this standard time from the basic observations. The first example, a study shows that the assembly operation for 30 cycles and then computed the average time per cycle, which is 18.75 minutes. Then the analyst assigned a performance rating of 0.96 and decided that an appropriate allowance was 15%, and this allowance factor is based on the workday. Now we need to determine the observed time, normal time, and standard time. Now many students look at the question and find, oh, there are 30 cycles and we need to find the total of all the 30 observations and then calculate the average. But here, the question already gave us the average time per cycle, which means the observed time is already given because observed time is the average time from all the observations and it is already given as 18.75 minutes. So we have the observed time equals to 18.75 minutes. Next, we have the performance rating of 0.96, and normal time is defined as observed time multiplied by this performance rating. So we can calculate normal time equals to observed time 18.75 times the performance rating of 0.96, which get a result of 18 minutes. So a performance rating that is less than 1 minute means that the normal time is shorter than the observed time, which basically means that the employee's performance under observation actually is lower than their normal performance. Next, we need to calculate the standard time. Here we have an allowance of 15%, but this allowance is based on the work day. It means that during any working days, 15% of time can be used or will be used to do something else except of working. So we have A equals to 15%. However, the allowance factor is determined by 1 divided by 1 minus A. Basically, it means during any working day, only 85% of time will be used to work. So the standard time will equals to 21.18. Now let's take a look at another example. Here we have some observations. Now it's a time study of an assembly operation again, and we have some observations, and we have the performance rating of 1.13, and allowance is 20% of job time. So it's different from previous example. So it is 20% of job time, which means that for every 1 minute you work, you are allowed to take maybe break of 0.2 minutes, something like that. Now we need to determine the appropriate standard time. Although the standard time is the one that we need to calculate, but we know that to get the standard time, we need to calculate the observed time, and from observed time get the normal time, and the last step is to get the standard time. Now here we have basically 9 observations, and the total time of these 9 observations is also given as 10.35. So next, let's take a look at how do we solve the problem step by step. We have the performance rating of 1.13, which will be used to convert the observed time to normal time, and the 20% of the allowance will be used to convert the normal time to the standard time. So we basically have this given informations. The total observed time from these 9 observations is 10.35 minutes, and there were 9 observations. The performance rating is 1.13, and the allowance is 0.2. And again, this allowance is based on job per job. So observed time is the total observation time divided by number of observations, so 10.35 divided by 9, which give us an observation time of 1.15 minutes. Normal time equals to observed time multiplied by the performance rating. So 1.15 times 1.13 equals to 1.3 minutes. So this is the normal time. And the last step is to calculate the standard time from this normal time. So standard time equals to normal time multiplied by the allowance factor. So here the allowance factor is based on job. So we use 1 plus the A multiplied by the normal time will give us a standard time of 1.56 minutes. So there is another part of the work measure is we need to determine how many observations we need to have so that the result will be accurate enough. Basically, we know that the more sample we have, the more accurate the result will be. Now, there are two equations we use to calculate or find out the sample size or number of observations. Now, if we compare these two equations, actually everything else is the same except the denominator. One is A times x bar, where A is the desired accuracy percentage. So this is a percentage. X bar is the sample mean, which means that we hope the error will be within certain percentage of the sample mean. The other one will be maximum acceptable error. So these two equations basically answers the same problem, or they solve the same question. The only difference is depend on how we can use the error message. Is error message directly given, or the error message is given as a percentage of the sample mean? So this will determine which formula we use. Now we take a look at an example. So the time study want to estimate the time required to perform a certain job. Now a preliminary study yield a mean, which is a sample mean, of 6.4 minutes and a standard deviation of 2.1 minutes. The desired confidence is 95%. So how many observations will be needed if the desired maximum error is part A, plus or minus 10% of the sample mean? Now here we see that the error is expressed as a certain percentage of sample mean. So which means we need to use the first formula to do the calculation. So we have standard deviation equals 2.1, sample mean equals 6.4. The given 95% desired confidence lead us to a z equals to 1.96. So with all this given information, and we know the first formula to use because we have the error expressed as plus or minus 10% of the sample mean. So we do the calculation and found a value of 41.36. For all this sample size problem, the final result should always be rounded up. So we need to sample, or we need to have 42 observations. Now part B, see what if the maximum error is 1/2 minute? So 1/2 minute basically said the maximum error should not be higher than 0.5 minutes. So here the error itself is already given. Instead of like part A, we only give a percentage of the mean. So we need to use the second formula. Substitute everything into it. We found a final sample size or the number of observation equals to 68.